So in this video, we're going to walk through the IVF implementation in FAISS. So again, if we review our parameters, we do need to know the embedding dimension. And so our embedding dimension is 384. We're going to store that here in D. And we have in list, and here I've chosen to break our facts up into 5 clusters. And then for each question, I wanted to only probe 2 clusters at the max. We do have to set a quantizer. The quantizer here is just an object that's going to assign a vector. Whenever we build the index, it's going to assign a vector to a specific cluster. So it's what decides which cluster the vector gets assigned to. Then we're going to call the index IVF flat, and we're going to create an IVF index. We're then going to train it on our fact embedding. So it's got to be trained. Remember, it runs k-means under the hood, and it's got to cluster your data up into these 5 groups that I chose. And then it has to, once it's clustered it up, it's going to add it to the index. And then I'm going to add the nprobe hyperparameter. All right, so we're going to do top k is equal to 3. And again, it returns distances and indices just like I showed above. And here we go. So these are the facts that are returned for each question, and as you can see, they're pretty similar to what we got in the HNSW case. For this question, the first fact is Alan Turing. The second fact is the artificial intelligence was coined in 1956. The third one's different. This is the Turing test, and the third fact for this question in HNSW was machine learning is a subset of AI. So maybe this has to do with the number of clusters. K-means also is random, and so maybe we can fine tune it a little bit more. We can see here that for this one, what technology enables computers to understand and generate language? Natural language processing came first, so that's good. Self-driving cars came first for this question. So we're doing pretty good here. And definitely feel free to run this on a much larger set of examples that you have and play around with the clusters. Try to optimize using the elbow method. That's not covered here, but definitely consider optimizing the number of clusters before you ever create that index so that you can get the best retrieval possible. And so that's how you can create an IVF index using FAISS.